Hello everyone, this is Sureka from CSCA of PVRD Nursery. I'm here to present you a topic of duality and Boolean ring. Duality and Boolean ring are the two topics which are related to Boolean algebra. So, firstly, we'll know what is the Boolean algebra. Boolean algebra is an algebra of logic which gives the resultant values either true or false. And let's get into what is duality. Let me present you this. So, duality. So, De Morgan, who's a mathematician who has given us few laws which are called as De Morgan's laws, which describes the relationships between the statements or by using logical operations. We all know the fundamental logical operators such as and, not, or, right. So, the operations done using these operators is called as the logical operations. So, these laws has given a fundamental to the principle of duality and Boolean algebra. What is a duality? Duality is a symmetry or interchange of certain operations in Boolean algebra, like replacing AND operation with OR operation or operation with AND operation, etc. So, before going to the detail of duality, there are applications of duality. There are many applications in duality, mainly in electronic systems such as digital system design, optimization, and also the analysis contributing to the efficiency and reliability of electronic systems. See, what is a duality? In Boolean algebra, duality is a fundamental principle that establishes a relationship between statements involving AND operator or 0 and 1, which we call as true and false respectively. According to the principle of duality, the Boolean algebraic statements remains valid when we replace AND with or replacing OR with AND, replacing 0 with 1, or replacing 1 with 0. So the ultimate condition of the duality is it should be the original expression and also the dual expression should be logically equivalent, means they should be equal. So the expression which we get after the applying of duality and the original expression we already have should be logically equivalent. So this says the principle of duality. So we have a note here. So while replacing and with or and by replacing 0 with 1, there'll be a variables like a, b, c. So we no need to change them. They remain constant in this expression. We no need to replace the variables with anything. So variables doesn't get complemented and they remain same. So now let's see few examples. So here in the table we can see that this is an expression, original expression. This is the dual expression. Here one is equals to zero. Then one is replaced with zero and zero is replaced with one. In the same way, here we see an AND operator here. One into zero is equals to zero. Here this AND operator is converted into or replaced into OR operator. In the same way, A into zero. So here A is a variable. We already discussed that A doesn't change. Therefore, A remains same. In the same way, we have seen here A, B, C. There are three variables. The and operator is also there. So and operator is changed to or operator, but the variables remain same. So these are the few examples. Let's consider an example in so that we can understand this principle of duality in detail. So S is equals to A plus B into C plus 0 plus D. Here it is an expression. You have to apply the principle of duality and to find the dual expression. So how can we apply the principle of duality? Here we have AND operator, OR operator and operator, and also we have 0. And we have variables here. So variables remain same. And this OR operator is replaced with AND operator, and here AND operator is replaced with OR operator, and here 0 is replaced with 1. So by applying the duality, we get this dual expression. We'll break this expression into step by step so that we can understand how these replacing has done. So here, now if we have break down to the step, we are replacing AND with OR. Here we have seen AND operator in the original expression. So it is converted into OR operator or replaced with OR operator and replacing OR with AND. So here we have seen that OR operator was there. It's like OR operator was replaced with AND operator. And we are replacing 0 with 1 and 1 with 0. We have 0 in this expression where it is replaced with 1. So here we have got the dual expression. So here by this we have obtained the dual expression. So this dual expression and also the original expression we have should be logically equivalent. So this is an example of principle of duality. So this is the concept of duality. Now let's get into the concept of Boolean ring. So in the same way, Birkhoff and MacLean has introduced the concept of Boolean ring, so as part of their universal algebra. So they define the Boolean rings as algebraic structures satisfying specific properties in the Boolean algebra. So what they have said the Boolean rings are combine the structure of algebraic structures with the Boolean algebra. So those are called as Boolean rings. So Boolean rings are mainly used in the logical design and also in the computer science. Now let's see what is a ring. First of all, we have to know about what is a ring. Ring is an algebraic structure consisting of a set equipped with two binary operations. Usually there will be an addition operation and also the multiplication operation. Usually a ring is denoted as like this: r, comma plus, comma into. So here r is a set. Plus is an addition operation which is defined on R. And dot or else multiplication symbol is a multiplication operation which is defined on R. So this addition operation should satisfy closure property, associative property, identity property, and also the inverse element properties. So this addition operator should satisfy these uh, four, op- four properties, and the multiplication operation should satisfy closure property as well as associative property. So this is the concept of ring. Now let's see what is a Boolean ring and how this ring is converted into the Boolean ring. So, a Boolean ring is a special type of a ring where the set R is a Boolean algebra. So, here in Boolean algebra, in the same way, the ring has two operations, right? Binary operations, right? In the same way, Boolean ring also have a binary operations. Usually, they are denoted as OR. That symbol is nothing but Boolean OR, and this is Boolean AND, along with unary operation, which is called as negation or else not. So a Boolean algebra must satisfy the following properties. They should be closure, they should be associative, they should be identity, and also the inverse. And we will see the other two properties also. Closure property. For any A comma B in the set, A or B should A or B and A and B are also in the set. So A or B and A and B should be present in the set. And associative law. A or B or C is equals to A or B or C, and A and B, B and C is equals to A and B and C for all A comma B comma C in the set. So this gives the associative law. And identity elements. So we all know that there exists 0 and 1 elements, right? So A or 0 should be equal to A. A and 1 should be equal to A. These are all A in the set. So this gives us the identity elements. Now let's see the other two properties it should follow. Those are negation properties. So for A, the opposite or the negation of A or the opposite of A is called as A complement or negation A. So therefore, A or negation A should be equal to 1 and A and negation A should be equal to 0. So this, if it follows this property, if it follows this condition, it follows that property. And we all know the distributive laws are the combination of both and or operators. So here we see A and B or C is equals to, it multiplies like this: A and B or A and C. In the same way, here A or B and C gives that A or B and A or C. So this is the distributive law. It should follow the above five laws so that it satisfies the Boolean ring. And also, Boolean ring also gives us Boolean operations mainly are addition and multiplication. We know that addition is nothing but A or B. Or operators gives the addition. A and B gives that multiplication. So A plus B is equals to A or B and A dot B is equals to A and B. So now let's see a example so that we can understand the Boolean ring in very easier manner. So a ring R, we all know that a ring is denoted like that. A ring R, comma plus in 2 is said to be a Boolean ring. So if A square is equals to A for all A belongs to R, that means it should be idempotent. So if A square should be A, means every element square should be equal to that element itself. So now let's see an example here. So here we have Z6 plus and into is here this example. Actually, it's not a Boolean ring. Why it is not a Boolean ring? We'll see. So we all know that a square is equals to a. That means every element square means every element if you multiply with the same element should give the that element itself, right? Here we'll see 0 into 0, it gave 0. So 0 satisfies. 0 element satisfies the Boolean ring concept. 1. So 1 into 1 gives 1. So it gives the same element, therefore it satisfies. Let's consider 2. 2 into 2, it gave 4, right? So it is giving 4. Therefore, that this 2 element doesn't satisfy the Boolean ring. And if we again observe 3, 3 into 3, we got 3 again, right? So 3 into 3, we got 3. Therefore, it satisfies the Boolean ring. Now let's consider 4. 4 into 4 gives the 4 value. Therefore, it satisfies the Boolean ring. And 5 into 5, it gave 1. Therefore, it doesn't satisfy. Only few elements like 0, 1, 3, 4 has those 4 elements only satisfied the Boolean ring. Therefore, that is not a, therefore, this whole set is not a Boolean ring. Now let's extract these elements like 0, 1, 3, 4 together and together into a set B. Therefore, those elements satisfy the Boolean ring. We'll see that. See, let B be the idempotent elements. So we've already know that that Z set doesn't satisfy the Boolean ring. So we've extracted few elements which are satisfying Boolean ring. So what are these elements 0, 1, 3, 4? These are the elements in Z6 are satisfying the idempotent. These are called as idempotent elements. So therefore 0, 1, 3, 4 and 0, 1, 3, 4. So here if we observe 0, 0 gives 0 and 1 into 1 gives 1, 3 into 3 gives 3 and 4 into 4 gives 4. Therefore, it is satisfying the idempotent law and therefore it is a Boolean algebra. And for addition also, we use this operation and for multiplication, we use this operation. Therefore, by this we can check the given set as Boolean ring or not. So this is the concept of duality as well as the Boolean ring. Thank you.